So we are going to see the other question on statistics topic, Advanced Mathematics Paper 1, ACSEE, Advanced Certificate of Secondary Education 2024. Now, the question says, the mean of 200 numbers was 50, but on rechecking, it was found that 92 and 80 were incorrect numbers. Now, find the correct mean if the wrong numbers were replaced by the correct numbers. Then now there was data cleaning, and now these wrong numbers were corrected. So were replaced, 92 and 80 were replaced by 192 and the 88 as part of correction. Now, from that part of correction, we are supposed to find the correct mean. Now, if that to be the case, the solution for it we can see as follows. Here in case 1, we are required to find the correct mean if the incorrect numbers, these 92 and 8, were corrected by 192 and 88. The first thing that we are going to see, we need first to know the incorrect sum. Incorrect sum can be obtained by taking all the numbers times the mean. So if you take all the numbers where 200 numbers, if you times by the mean, now you get the incorrect sum. So this was the total but was incorrect. It means it contains these incorrect number 92 and 8. Now, after having known the incorrect sum, that is 10,000, then now we are provided with the information that incorrect numbers were 92 and 8, and the correct numbers were 192 and 88. Now, from these two cases, we need to know the sum of incorrect numbers. So the sum of incorrect is the matter of taking 92 plus 8. As here, we get 100, and sum of correct numbers, we get 192. We plug that 88 to see what was the sum for the corrected numbers. So here we get 280. Now, the correct sum, how do we find out the correct sum? It is given by this formula here. Corrected sum is less more to incorrect sum. We minus sum of incorrect numbers, then we add the sum of correct numbers. So it means here, if you take incorrect sum minus sum of incorrect numbers, it means now you get something that's when you add with sum of correct numbers, you end up getting the corrected sum. So here, incorrect sum, we have 10,000, as we have seen here earlier, minus sum of incorrect number, here was 100, that's 92 plus 8. So that was the sum of the wrong numbers. And now we add the sum of correct numbers. So the correct number after data cleaning was 192 and 88. So that results the sum of 280. Now, if we perform our operation here, we get corrected sum. It is 10,180. So that's become the correct sum. But after getting the correct sum now, we need to get the corrected mean. That's what was asked from the problem here. That find the correct mean if the wrong numbers were replaced by these 192 and 88. Now, the idea for obtaining this corrected mean is less more to say, corrected sum you divide by the total numbers. We know the total numbers here provided earlier was 200. So corrected sum, after having corrected sum here, 10,180, now we place it here, we divide by the total numbers, which is 200. So when we divide here by scientific non-programmable calculator, you end up getting 50.9. And this now is what now is needed. So we say that will be the corrected mean, is actually here from the problem. That's easy, 50.9. And earlier, the mean was 50, but was accompanied with wrong numbers. That is 92 and 8. But after rechecking and having made data cleaning, by replacing these numbers by the correct number, that's where 192 and 88, now we end up getting now the corrected mean, that is 50.9, which is very okay now for the use. And up to that point, we have managed to answer part A. Now, let's see for part B. So in part B now, we are required to use the coding method and the assumed mean of 21 to calculate the mean and standard deviation for the following data. So here we have a table where we can see the marks that are group D in the group data, as you can see, from 0 to 60 until you reach here the last group, that is at the 60 over 42. And now they are distributed with their frequency, as you can see here. Now from this table, we are required to use the coding method now and the suggested value, which is assumed mean 21, to find the two statistical averages, that is mean and the measure of dispersion, that is the standard deviation. Now how to do it? Now in case B, so we start with mean. So required to find the mean by coding method. So now we start with the mean by the coding method. Now, if you remember, the coding method that connects the idea of deviation, and how do we obtain the coded value? Solution here, the coded value u sub I is obtained by taking deviation. Now you divide by the class size. So if we take deviation divided by the class size or the interval size within these groups, now we obtain the coded value. So if that to be the case, it means here, if you want to replace deviation by coded value, the same as say ui, the coded value times the class size. Now from the formula of mean, using the suggested value or assumed mean, this formula here, now we are going to replace D by the coded value. So this, it is going to end up A plus the summation of F, then D now it's UI times C. Then now you divide by total frequency. So at the end of the day, we have A plus, this C is constant, the class size is constant. So we take it out. Now we have C now summation of FUI, then you divide by the total frequency. Now that's become the formula for mean using coding method. Now from here, we are going to prepare a table. Our table will comprise of frequency, the coded value, and the other important issues like class marks and deviation. So here we say now consider a table below. Now from this table, we have several columns where here we can have the marks. So here, staying the marks, the class mark. We have the frequency. Now we have the deviation, that is class mark minus the assumed mean, which is 21. And here now we have the coded value, that is deviation over class size. And here now we have frequency times the coded value, as the formula shows. So now the data 0 to 6, 6 to 12. Then here we have 12 to 18. We have 18 to 24. And then now we have 24 to 30, and then 30 to 36. We have 36 now to 42. So the frequency here it is 2, then 3, here we have 5, then we have 10, we have 3, we have 5, and we have 2. And what is our total frequency? This and that is 5, 10, 20, 28, 30. So the total number, total frequency, it is 30. Now deviation. Deviation, we take class mark, we minus the suggested value, the assumed mean. And here we are already given this assumed mean, that is 21. So we find now the class mark. Class mark is the average within that group. So we take 0 plus 6, then we get 60. We divide by 2, now we get what? 3. So here becomes 3. It means lower limit plus upper limit. Now that sum you divide by 2. You get the class mark. But to get these class mark that are proceeding, we need to add the interval size. That is a simple technique. If you get to know the simple the interval size, now you just add so as you can get the proceeding class marks. Now here, the nature of the data, these are class boundaries. As you can see, if they are repeating, the upper class limit of the previous class, if it is going to repeat at the lower class limit of the next class, that's represent class boundaries. So for we to find the interval size is very simple. You just take the real upper limit, you minus the real lower limit. Then you just get the interval size. So this minus this, we know it is 6. So we add 66. So here will be 9, add 60, 15, add 6, will be 21, add 6, 27, add 6, we get 33, add 6, we get 39. So now, you can just use your scientific calculator now to get these deviations. Or if it's just simple number, you can just go on mental operational skills. You can just subtract direct. So for example, x minus 8 means now 3 we minus 21. So here we know it is negative 18. Yes. So 9 minus 21, we know 9 when you subtract this one. So 9 minus 21, we end up getting negative 12. Here is negative 12. 15 minus 21, we end up getting negative 6. Yes. And now 21 minus 21, we get 0. 27 minus this 21, we get 6 positive. Then 33 minus 21, we get here, it will be 2, then 1, then 12 positive. And 39 minus this much, we get now 18. So that's how we are going to get this column for deviations. As you can see, positive and the negative numbers. Normally, it used to be like that. UI, that is the coded value. So we take these deviations now that we were obtained now, we divide by the class size. So deviation is negative 18 divided by the class size we said earlier. These are class boundaries, so we take the real upper limit minus real lower limit, we just get the interval size. And that will be 6. So now you take negative 18 divided by 6, we get to negative 3. Negative 12 divided by 6, we get to negative 12, negative 2. Next 6 divided by 6, we get to negative 1. 0 divided by 6 is 0. 6 divided by 6 is 1. 12 divided by 6 is 2. And 18 divided by 6 is 3. So what next? Now we multiply frequency and the coded value that we have obtained. So 2 times negative 3, we get negative 6. Then 3 times this much, we get negative 6 again. 5 times negative 1, it is negative 5. 10 times 0, now we get that 0. 3 times 1, we get 3. 5 times 2, it is 10. And 2 times 3, we get 6. So here at the end, we have summation of UIs equals to what? So we add these FUIs. So maybe I can start with positive. This and this is 16. 16 now. If you add 3, you get 19. So 19. Now we minus this and that. We minus 5. We minus 6. We minus 6 again. So we end up getting 2 positive. We get that to positive. Yes, because this and this negative 12, negative 17, and here we have 19, so we get positive 2. So after getting that, now we go to the formula. We have everything now. We have all the values from the ribbons. We have A, we have C, we have summation of FUIs, that much 2, and N we know it is 30. So it's a matter of plugging every value for the respective identity. So mean, so now we say the mean, that is X bar, which is A, now we plus C, summation of FUIs over N. So here will be, it is 21, now we plus C. Our C, we know it is 6. Then brackets, here it is 2 over 30. So at the end of the day, we get 21. Now we plus this and that, we get 5. So 2 over 5 is 0.4. So here now we get 21.4. So that's now will be the mean. So by coding method, that will be the mean by coding method. And up to that point, we have managed to find that statistical average mean. So now we are moving forward to see how we can calculate this dispersion measure, standard deviation, using the coded value, using the coding method. And now let's see it, how we can do it. So now we say we are required to find the standard deviation. Yeah, the standard deviation by coding method, by the coding method. Now, if we go back and recalling some concepts on the standard deviation, we know that standard deviation equals to the root of the variance, that is fd squared, summation of fd squares over n. But very fortunate, we know that d, according to the coding method, d, for example, here is given by, it's a UI, the coded value, u times the class size. So if now we get substitute here, it will be the square roots of the summation of f. Now, if this is d, it means d square now is less more to ui square then times c square. So it is going to be ui square then c square. Now you divide by n. So at the end of the day here, if we factor out the constant, this much, this c square is a constant, we take it out. This ui is a variable, so we don't consider it as constant. So this one, it is going to be now c, then the root, summation of fui square, then over n. That is what now we are going to get as a formula of standard deviation. This now will be the formula. So from the table that we are going to prepare, we need to show all these parameters, all these identities that are found in the formula. For example, frequency will be there, ui and ui square and f of ui square. So now we can consider the same table, but we can add the information that is missing now. It means the missing information here, it is ui square and the f of ui square. That is what now we are in need of. So we can modify the same table. So here the same table. by adding important information. So now it can be like this way. So here we need to introduce UI square and f of UI square. So those are the very important information. But UI, we are lucky enough that we calculated earlier from part T, from this part of mean that was here. And now square it means we just square. -3 square, we get +9. Here it is 4, 1, 0. And now here it is 1, then 4, then 9. Now the product of frequency and that UI square. So here it is 2 times 9, we get 18. 3 times 4, it is 12. 5 times 1, we get 5. 10 times 0, we get 0. 3 times 1, 3. 5 times 4, it is 20. And 2 times 9, it is 18. So here down, we have summation of UI square, which equals to what? Now it's a matter of adding from the scientific non-programmable calculator. If we add all these now, we're going to obtain the sum of frequencies and the UI square. So that is 18. Now we plus 12, we plus 5, we plus, that would be 23, then we plus 18. So we end up getting 76. So here it is going to be 76. So now from the formula now, standard deviation, which is C now, then summation of FUI square gets 76 over n, that is 30. And remember here at C now, we know it is 6. We take this minus that, or this minus that, we get 6. So from this calculation here, now if you just plug it all into the calculator now, 6, then the root, bracket 76 now over that 30 total frequencies. So we end up getting 9.54. Here it is 9.54. It's 9869109. Now this is approximate to 9. We can approximate to 2505. So we end up getting the standard deviation. So we can say now the standard deviation, is approximate 9.55. So that will be our standard deviation by coding method. And up to that point, we have managed to answer the problem, the part B of that question number 4 that appeared in Advanced Mathematics Paper 1 in the year 2024. Thank you very much. Now keep watching for the next sessions. Thank you.